Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to figure out what the combustion of a thymol is from bomb calorimetry given some information that we're given. So let's get into this. Okay, so here in this problem we have a 1.567 gram sample of naphthalene C10H8 solid is completely burned in a bomb calorimeter, and a temperature increase of 8.37 degrees Celsius is recorded when a 1.227 gram sample of thymol, which is C10H14O solid, is burned in the same bomb calorimeter. A temperature increase of 6.2 degrees Celsius is recorded. If the enthalpy of combustion in naphthalene is negative 5,153.9 kilojoules per mole, what is the enthalpy of combustion of thymol in kilojoules per mole? So let's get into this. So now the first thing to notice is that we're given here the the heat of combustion for naphthalene, which is a negative 5,153 joules or 0.9 kilojoules per mole. So notice they give us grams of thymol and they give us grams of naphthalene, but they want kilojoules per mole. So the first thing that I think we should do is convert the grams of each of our substances to moles. So let's go ahead and do that. So I'm going to take 1.567 grams of naphthalene. I'm just going to say NAF over 1. And I'm going to use the molar mass to convert that to moles. And so you got to calculate the molar mass from the formula. And when you do that, you get 128.174. 128.174 grams of the naphthalene. Again, naphthalene has the formula C10H8, so you just add those up to get this number here. And of course, we're going to have 1 mole of the naphthalene on the top. So grams of the naphthalene are going to cancel out. And then you end up with how many moles? 0.01223, 0.01223 moles of the C10H8. Okay, so this is our naphthalene. And let's do the same thing with our thymol. We're given 1.227 grams of thymol. So 1.227 grams. I'm just going to put thymol. And then we're going to use the molar mass of thymol, again, from the formula C10H14O. And when we calculate that, that's going to be 150.221. 150.221 grams of the thymol, 1 mole of the thymol on the top. Grams cancel out. Now I get moles. And when I calculate that, I get 0.008168, 8168 moles of the C10H14O, which is our thymol. Okay, so now that I have moles of each, I can now calculate the amount of, how should I say it? Well, the first thing I need to do is find out what the specific heat or the heat capacity of the calorimeter is, and then use that in the next problem. So here we have all the information we need. They're giving us the heat of combustion of naphthalene, right? They're giving us a temperature change of 8.37 when we burn the naphthalene in a bomb calorimeter. And remember, the bomb calorimeter, we're going to assume, is not picking up any water or is not picking up heat. And so we're going to figure out what the amount is picked up by the water. I'm sorry, I misspoke. The specific heat of the calorimeter. So what we know is, remember that during the reaction, we're doing a combustion. So we're combusting naphthalene. So we have this many moles of naphthalene. We're burning this, and this is going to release heat. That heat is picked up by the bomb calorimeter. So we need to figure out what the specific heat of the bomb calorimeter is in order to find out the heat of combustion for the thymol. Here we're given the heat of combustion of the naphthalene, so we can use that in our equation. So we know that the heat that's released by the burning of the naphthalene is picked up by the calorimeter. So if you remember, the heat that's released by the reaction is going to be equal but opposite to the heat picked up by the calorimeter, which is in this case C, which is the bomb calorimeter. The bomb calorimeter has water in it, so we're just going to include all of that in the calorimeter. And so here they should be equal but opposite. So the reaction is losing heat, so I give that a negative. The calorimeter with everything in it is absorbing the heat. And so we have this relationship that you should remember. Now we can bring this to the other side. So we can add the Q of the reaction, to add that to both sides. And so when we end up here, this is going to cancel out, give you 0. So we have 0 is equal to the Q of the reaction plus the Q of the calorimeter. So basically the heat that's released from the calorimeter plus the heat the heat released by the reaction plus the heat absorbed by the calorimeter. So now we have the equation. We can fit all of this in. So now we can take this and plug in our values. So the Q of the reaction, what is Q of the reaction? That's going to be equal to the heat, the enthalpy of combustion of the naphthalene, which is what we're given here, times the number of moles. Why is it multiplied by the number of moles? Because look at the units. It's kilojoules per mole. Q is a amount of heat released. Heat is a energy unit. It should be just joules or kilojoules. So here I have kilojoules per mole. I need to get rid of the moles. Since moles is on the bottom here, that means I need to multiply my moles to get rid of moles. So the formula to get the amount of energy that was released by the reaction is going to be the heat of combustion multiplied by the number of moles of the naphthalene that was combusted. In this case, this amount. So N is the number of moles. So it's going to be delta H of the combustion, the enthalpy of combustion multiplied by moles for Q of the reaction plus the Q of the calorimeter, right? And what's the calorimeter? That's going to be the Q of the calorimeter is going to be the specific heat or the heat capacity, in this case, heat capacity of the calorimeter. And the heat capacity of the calorimeter is going to be also in an energy unit, kilojoules per degree Celsius. So the calorimeter, the heat capacity of the calorimeter is going to be either joules or kilojoules. We're going to say kilojoules since we have kilojoules here. Multiplied by a temperature, that's just the units of heat capacity, right? So that means that we're going to have to multiply the heat capacity by a temperature or a temperature change. We have a temperature change. So then the formula for our QC is going to be the heat capacity C of the calorimeter multiplied by temperature change. So now that we can now plug in everything we're given and solve for this specific the heat capacity of the calorimeter. So now this here, negative 500, so this is going to be 0 is equal to negative 5,153.9 kilojoules per mole, multiplied by the number of moles, which is 0.01223, 223 moles of the naphthalene. Now we got this done, and now it's going to be plus the specific heat of the calorimeter multiplied by the temperature change. We're told that the temperature change is 8.37 degrees, so we're going to put that in, multiplied by 8.37 degrees Celsius. This is positive because this is negative releasing heat. So if this is releasing heat to the calorimeter is absorbing heat. So the change in temperature should match the gaining of heat. So if you're gaining heat, that means the temperature is going to rise. So the change is positive. So that's going to be positive. Okay, so now all we need to do is solve the equation. So I'm going to go ahead and erase this. Give myself some room. So this times this, what does that give me? $63.00936. So this times this is going to give me 63 or negative 63.00936. And so the moles are going to cancel out here. So that's going to leave me with kilojoules plus, and that's going to give me the heat capacity of calorimeter multiplied by 8.37 degrees Celsius. This is equal to 0. If I add 63.00936 kilojoules to each side, I can add that to this side, 63.00936 kilojoules. So the negative kilojoules, the positive kilojoules cancel on this side. Now I have 0 plus 63.00936 gives me 63.00936 kilojoules. And now that's equal to this, which is the heat capacity of the calorimeter multiplied by 8.37 degrees Celsius. Now all I need to do is divide by 8.37 degrees Celsius on both sides, 8.37 degrees Celsius. This cancels out, leaving me with the heat capacity of the calorimeter. And then I just divide this. Notice I'm going to get kilojoules per degree Celsius. So when I divide this, I get the heat capacity of the calorimeter is equal to 7.528. 7.528 kilojoules per degree Celsius. So now I have the heat capacity of the calorimeter. Now I can use that in the next calculation to find the heat, the enthalpy of combustion for the thymol. So this time I'm going to use the exact same setup, exact same equation, but now it's going to be using the moles of thymol to find the heat of combustion or the enthalpy of combustion of the thymol. So now I'm going to go ahead and erase this. I don't need this anymore. So I've got the heat capacity of the calorimeter. So now I have this. They're giving me, I have the moles of the thymol. So now again, it's going to be the Q of the reaction, which is the combustion of thymol, equal to the Q of the calorimeter, right? So the reaction, this is going to be negative. It's releasing heat. This is going to absorb heat. So again, I'm going to end up with the same equation, 0. I'm going to add Q of the reaction to both sides. So it's going to be Q of the reaction plus Q of the calorimeter. This time, the Q of the reaction is going to be equal to the enthalpy of the reaction of thymol multiplied by the moles of thymol. So again, it's going to be delta H of combustion of the thymol this time. Again, multiplied by the number of moles of the thymol that were burned, which is now I have here, plus, again, the heat that's absorbed by the calorimeter, which is going to be the specific the heat capacity of the calorimeter multiplied by the temperature change of the calorimeter. This time the temperature change of the calorimeter is 6.2 degrees Celsius. It's positive again because the calorimeter is absorbing heat, so the temperature is going to go up, so it's a positive change. So now all I have to do is plug everything in. The only thing I won't have is the combustion, the enthalpy of combustion for the thymol, which is what I'm looking for. So this is going to be 0 is equal to delta H combustion of the thymol multiplied by the number of moles, which is 0.008168 moles, plus this, plus the heat capacity of the calorimeter, which I calculated here, which is 7.528 kilojoules per degree Celsius, multiplied by the temperature change, which is 6.2 degrees Celsius, so 6.2 degrees Celsius. So notice the degrees Celsius cancel here. Now notice that I have kilojoules left and I have moles, and they're asking me for kilojoules per mole. So this is looking good. Okay, now all I need to do is do the calculation. I'm going to multiply this together. When I multiply that together, I get 46, 67, 36. So this is going to be, delta H combustion of the thymol multiplied by the moles of the thymol plus, and then this was 43, let me double check, 46, 67, 46.60, 6736, and this is kilojoules. So this is kilojoules here. Now notice I want to get this by itself. I want to get this by itself. I'm going to bring this over here. So I'm going to now subtract 46.6736 kilojoules from this side. And I'm going to subtract it from this side too. 46.6736 kilojoules. So 0 minus that is going to give me the same one. I'm going to erase this to give myself some room. So now I have a negative 46.67 0.6736 kilojoules equal to the rest of this here, which is my delta H of combustion for the thymol that I'm looking for, multiplied by the moles, 0.008168 moles of the thymol. So now all I need to do is divide both sides by the moles, 0.008168 moles of the thymol. Divide this by 0.008186 moles. And now I have this cancels out. So delta H of combustion for the thymol is in kilojoules per mole. All I need to do now is divide that, and I get negative 5714, negative 5714 kilojoules per mole. And that is the enthalpy of combustion, the heat of combustion for thymol. I hope that was helpful. I hope you enjoyed the video. If that was helpful, if that you learned a lot from this video, then please, by all means, like the video, share the video, hit the notification bell. Do me a favor, subscribe to my channel, please. When you hit that notification bell, hit also the click on the all so you can be notified by all the videos put out. Also, I have a like button over here. Please hit that like button. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem that you need help with, or a topic you would like me to cover, write that down below so I can do that for you. I would love to do that for you. Thanks for joining me, and have a great day.